Alright guys, last lesson for the grading period, for the year for that matter. I'll add additional lessons that we didn't cover if you wish to do them at your own leisure during the summer or before pre-cal starts next year to better prepare. So we didn't have a chance to cover everything we normally would have. Alright, rational functions. So rational, ratio, so it's a fraction. It's a function of the form p of x over q of x. P of x and q of x are just any polynomial. Ax squared plus bx plus c, that's a polynomial. That's a trinomial, a quadratic one, any cubic one or whatnot. So that's what those are. You cannot divide by 0. So your denominator, q of x, cannot be equal to 0. When the bottom is equal to 0, we have discontinuities, holes in graphs, asymptotes, all sorts of things do occur. So let's go ahead and graph a few and then we'll define a lot of terms. So 1 over x, that's going to be your parent function for rational functions. So let's go ahead and plug in and just look what's happening with the table. So 1 over, I go back. Let's fix this. All right, 1 over negative 3. All right, so roughly negative 0.33333. 1 over negative 2, so 0.5. 1 over negative 1, so negative 1. 1 over negative 1/2, so that's going to be negative 2. 1 over negative 1/3, negative 3. 1 over 0, that is undefined. Cannot divide by 0. 0 fits into 1 an infinite amount of times. 0 plus 0 plus 0, you'll never reach 1. Next one, 1 divided by 1/3, so that's 3. 1 divided by 1/2, that's 2. 1 over 1, 1/2, and 1/3. All right, let's plot these. Let me zoom out so we can get a better visual of it. That's a bit too much. Let's try 125. All right, I'll stick with this. We can see the table, and I'll zoom back in. So what do we got? What do we got? What do we got? What are some easy points we can plot? Negative 3, negative 0.33. Let's go ahead and throw some marks in here. All right, so negative 3, 1, 2, 3, 0.333. So it's close to the x-axis. Looking about somewhere in there. Negative 2, negative 1/2. So I'm about right there. Negative, whoops, I'm on the wrong side of the x-axis. I apologize. Let me go back and fix this. Negative 3, negative 1/3. So on the negative y value, negative 1/2, negative 1. Next point, so I'm right here now. Negative 1/2, negative 2. Negative 1/3, negative 3. And as you can see here, let me just block out these. As the x gets closer to 0, negative 1, negative 0.5, negative 0.33, the y coordinates are getting further from 0, negative 1, negative 2, negative 3. Then you would get negative 4 for 1/4 as the x value, and so on and so on. When x is 0, we cannot divide by 0. So it just gets closer and closer to the y-axis, but it'll never ever hit it. On the other end, as x gets larger and larger, negative 1, negative 2, negative 3, the y coordinate gets closer to 0, -1, -0.5, -0.33. So this is one branch of the function. On the other side, you're going to have similar behaviors. Let's go ahead and get that going. X is 1/3, the y is 3, x is 1/2, the y is 2, x is 1, x is 2, you get 1/2, 1/3, 1/4, 1/5. So it gets closer and closer to 0. The y coordinate does as x gets larger. As x gets closer to 0, the y coordinate gets larger and it goes this way. All right, so that's the graph of 1 over x. A few things, x cannot be 0, as you can see here, cannot divide by 0. And that is called, so we're going to define that here. Let's do domain and range and we'll go back to characteristics of it. All right, x cannot be 0. Oh, when that happens. All right, domain, x cannot be 0. My range, so the range is kind of interesting. So my range, bottom to the top, right? So we're here, negative infinity, all these negative values. It'll never hit 0 though, along this track, on this branch. What's going to happen? You get 0.5, 0.33, 0.25. It gets smaller and smaller, but never hitting 0, as far as the y coordinate is concerned. On the other branch, it picks up right above 0 and does this up to infinity. So your range is all values except 0. These boundaries, if you will, are called asymptotes. See that? So we have a vertical asymptote here. The dashes. Dashes. Vertical asymptote there at the line x equal to 0. Horizontal asymptote there at the line y equal to 0. So the line x equal to 0 is a vertical asymptote. The line y equal to 0 is a horizontal asymptote. And we'll define those in the next section, or down here. So once we get to here, we'll define the asymptotes with a bit more clarity. All right, let's graph this other one, 1 over x squared. So we're going to have very similar behaviors. The difference, though, that we'll see is x squared. So x squared is always bigger or equal to 0. It's never going to be negative. Whereas on this first example, we had a lot of negative values because it's 1 divided by x. If x was negative, the y value was negative. That's not going to occur over here. So let's have at it. Let me zoom in. There we go. Give me a little more space to work with. So 1 over -3 squared. -3 squared is positive 9. 1 over -2 squared. 2 squared is positive 4. 1 over -1 squared is going to be positive 1. All right. That's what that looks like there. Nothing but positive values because we are squaring things. 1 over -1/2 squared. So that's 1 over 1/4. So that's positive 4. This one's going to be 9. You can plug in and see it. 1 over 0 squared is still 1 over 0. That's still undefined. Cannot divide by 0. So right away, the bottom is equal to 0 when x is 0. So your domain, all real numbers except 0. All right, I'll do a few more and then I'm just going to list the rest. 1/3 squared is 1/9. 1 divided by that is 9. 4, and we'll get 1 here. All right, let's do some plotting. Zoom back in. 125, 150. That works. And it went higher than 150. That is fine. Okay, let's plot this guy. If you notice, it's getting kind of messy in here. All the y values are positive. So this entire graph will exist in quadrants 1 and 2, everything above the x-axis. When x is larger than 1, it grows, or I'm sorry, the y values shrink a lot quicker than 1 over x because you're squaring it. If x is less than 1 here, the y values they grow fast, 4 and 9, because we're squaring as well. All right, -3, 1, 9. Let's go ahead and throw some tick marks here. So -3, positive 1, 9, so real close to 0. -2, positive 1/4. It should be less than half, but it's kind of hard to do that. -1, 1. -1/2, 4. 1, 2, 3, 4. -1/3, 9. So 4, 5, 6, 7, 9. So it's going to grow really, really, really quick. On the back end, it gets closer and closer to 0, never approaching it. You get 1/9 right here, 1/16, 1/25. It gets smaller and smaller, but never approaching 0. As you plug in numbers closer to 0, 1/2, 1/3, you're going to get larger and larger values, 4, 9, 16, 25, 36, 49, hence this blowing up this way. But we cannot plug in 0, so there's no point that we can put above the x-coordinate of 0, so there's nothing up here we can put. All right, that's one branch of this function. On the other side, we're going to have the exact same behavior. This is an even function where it's symmetric across the y-axis, and whether you plug in a positive or negative value, you get the same y-coordinate. What I mean by that is, if I plug in -1/2 or positive 1/2, get the exact same result, 4 and 4 in both cases. It's an even function when that occurs. That's the definition in mathematics. All right, so on the other end, 1/3, 9. There's some nice symmetry. Let's change colors. Oh, 1/2 and 4. 1, 1. Oh, what else? 2, 1, 4. So we're getting closer to 0. 3, 1, 9. So this end will look something like this. Okay. It still has the same asymptotes. We have a vertical asymptote here. Dashed lines is how you do it. Should be straight. The equation for that one is x equal to 0. We have a horizontal asymptote here. The equation for that is y equal to 0. And let's see if we get the formal definitions of that shortly. Oh, the range. The range is pretty cool on this one. It's the very bottom to the top. So it bottoms out at 0, never hitting it, and goes up to infinity. So we can do this a few ways. All the y's that are strictly greater than 0. If you want an interval notation, 0 to infinity, parentheses are on both ends. You're not hitting 0, you're not hitting infinity. If you want set notation, let's open up that birdie, all y's such that y is greater than 0. Kind of goes along with the inequality notation. All right, this will be the first part of the video. I'm approaching 15 minutes. And then we'll go to the formal definitions of an asymptote and look at a few more examples.